The second group of questions is traditionally Class D. Is it capable or not? And here I picked one picture that, in my opinion, illustrates these situations very well. When something new appears, well, someone invents something, and the crowd shouts, "Which? A woman can't be that beautiful. Such a small woman can't run that fast. A woman with 2 children must be fat. Hanger, burner." Jordan Bruno came out with the thesis that the universe is infinite. He was burned at the stake. I would have given up, but he was a tougher guy. Why does the market in general have such a negative attitude toward Class D? Because essentially it destroys the entire established business, and the first stage is denial. I just want to show you all the drawbacks of Class D. I had a presentation like that back in 2008 when we were working on our first developments. And let's quickly go through all the problems. This picture shows almost all the problems of a Class D amplifier. Class D technology is not new, but the industry wasn't ready because it's actually difficult to create. There were problems with the input circuits, with the modulator, and then there was a serious problem with operating in the on mode because the power supply couldn't handle it and developed specific issues. In this case, the MOSFETs didn't switch fast enough, so you had to make a very large reserve, and then there was a lot of noise because the MOSFETs weren't ready for this. There was nonlinearity in the output filters. There should be high-quality filters there. There was hysteresis, and we needed to solve it. So how should we approach this? We can be in this crowd and scream, Class D can't do it because it has sand on top and other issues. Or we can see the whole perspective of this technology and try to solve it. If we look at a story like Kodak, for example, they had the film market. I think they had 90% of the market. They had a lot of money, and when digital photography appeared, they couldn't invest in it and keep working. They said that film is the best, and where is Kodak now? It's gone. Their patents were bought up. LG bought their 4-pixel patent, and LG's organic light-emitting diode TVs are the best. They have that patent. Nokia's button phones were everywhere. Nokia was a very good manufacturer, but they didn't keep up with smartphones. What happened? Nokia is gone. It is a niche player now, so with Class D it's the same thing. We can pick a side or watch and decide or say that everything is bad. And indeed, the tasks that this so-called dead time is supposed to solve, it can't be that both MOSFETs are open at the same time. Yes, such a reserve was needed. The bigger the reserve, the more distortion. Today it was decided to use base pumping when we have what's called a half bridge in English. I don't even know how to translate that. When we don't have a bridge circuit, and when we do have a bridge circuit, let's say when we don't have a bridge circuit, this problem exists and it can be dealt with. There's a specific task set for this because these switches work as voltage multipliers. But if you have a full bridge circuit, everything is solved without any problems. And chips like TPA3255 have 4 channels, and the best connection is 2 channels in a bridge circuit to get stereo and 2 channels, even though there are 4 channels inside the chip. There was noise with transistors like this, so they made specialized transistors and solved it. And finally, the reason why so many companies that produced Class A and B amplifiers are no longer working or can't work in the field of Class D is because it requires completely different knowledge. We have very powerful pulses, there are analog circuits, everything is on one board, you need different knowledge. Either you hire these specialists or you don't have them. And it turns out that other players like IcePower, Hypex, companies that work in the professional market, these are more popular ones, are the ones who lead. Regarding transistors, a new standard has emerged for leadless transistors. Low noise, good cooling, new casings, and so on and so on. International Rectifier specialized on it, then Infineon bought them. Here's the difference between a simple transistor and a specialized one in how each behaves as a pulse. And we're talking about nightmare currents, Specialized transistors appeared where they are paired in one package to have very precise outputs. Filters have hysteresis, they're bad there, and there was also a problem that filters could only be set to one frequency. Today we have feedback after the filters. It's a complicated thing, but it's been solved. We have a clear amplitude characteristic for any load. There was a problem, we solved it. There were different ferrite issues, and you can see how it changes. Distortion at the output only changes by selecting the inductor components, but this was still 2008 and solutions had already been found. There are different developers here, but the Japanese were the first to solve the inductor problem. It's another level, and here I've picked out an inductor for you that we were also developing back then. It's a good manufacturer. It was one of the first to offer different solutions. This is Ferrox core. And as you can see, they cut the magnet, preventing it from saturating, and solved the hysteresis problem. Here we even wound it by hand and tested it, but there are none left in stock. You see, there's a cut here. It's filled in, but the ferrite is cut, and it immediately loses a huge amount of thermability. I don't know if that's the right term, but one needs more of these windings. But they found some kind of option. But it was considered cool. We used it in our own development. So when your mind tunes into finding solutions, everything becomes solvable. Well, here are different types of these inductors. Some are like this. These are also well used, good ones. We see these kinds a lot. We see fewer of these. They are present in various developments. A large air core one basically doesn't make sense, since these ferrites have already solved the whole problem. We get distortion through the filters. 3 zeros after the decimal point. Everything is solved. Everything is solved. The same applies to filter components like capacitors. But that was much easier to solve, and overall, here's what we get. Polypropylene capacitors are the best. Polyester ones are also fine. Basically, that's not a problem, but you can't use ceramic ones. If you see ceramic ones, throw it out, throw away that board. I've seen a few. Well, come on. I don't really know the theory, but they have different problems. I won't get into electronics. But the cost of these capacitors is relatively high if you use ceramic ones. You might save €1 or even less, maybe €0.50, but you absolutely can't cut costs here. That's the worst thing. And regarding gate drivers, in 2008 there were about 5 of them. Let's see what's there today. Here we have Infineon. It is a German company. They make chips for the automotive industry, and they're very strategic and good developers. As you know, in cars, microchips have to work from -50 to +70 degrees. It's a very difficult task. They're a good manufacturer, and they also produce these gate drivers. All the complexity we've talked about is already inside the chip. If you look at their brochure where they talk about their developments, everything is there. There's a small 3-phase strip. There's a solution for that. There's a bigger one. There's a solution for that too. They combine, they do everything. They give you all the hints, all their knowledge, offering you a whole range of gate drivers from low power to high power, and they're getting better and better. If there were about 7 back then, now there are already several pages more and more. Voltage is 500 watts. That's the range we're interested in. We're not interested in anything else. The same goes for field effect transistors. You can choose any for any power. Everything is available. They've even grouped them here by the loads they can handle, which is mainly current. There are different options. So, the range we're interested in, which is up to 500 watts, it's going to get cheaper and cheaper. Also, for less experienced developers, all the key references, design guidelines, and reference projects are provided, where everything is done correctly and properly. Regarding a circuit board, it is a complex thing, and all the grounding, component grouping, and so on must be done very properly. Developers need to know many things on a theoretical level, especially everything about grounding high current circuits. It's not an easy task. It's much more complicated than just doing A and B class amplifier, but if you do everything properly, then it will be fine. These hints are given to developers. If you look at the different Chinese boards that are produced, they take the Gerber files as they are, then tweak them a little, remove some unnecessary things, and might add another operational amplifier. But overall they use these reference designs and quickly enter the market. Not every developer in China is highly skilled. There are many developers who can assemble and replicate it. To build something like this from scratch, you need a top-tier developer. They must be extremely well trained in theory. And once again, I want to return to the key developer behind high-quality Class D amplifiers that are now outperforming high-end systems. That's Bruno Putzis. He worked on it from the very beginnings. Essentially, he solved many problems that already existed in integrated amplifiers. He's better known in the amateur environment since this company grew out of the amateur one. But he also created the entire Hypex lineup, and now they have a separate engineering company there, working right at the cutting edge, focusing on the last 2% of quality, with a whole group of top engineers. And I recommend keeping an eye on them and this company Purify. Reading their blogs? Yes, in English it might be a bit difficult, but not too much. They're popular science, so everything is understandable. And the second one, who we know less about, there are two other developers, Patrick Bostrom and Lars Press Peterson. Many developers rely on them. That's IcePower, its key developers. And if you want to keep up with the latest news and developments there, these two guys are also top-class specialists. They have whole teams behind them. It's even bigger. But when you read their articles, not just in the professional world, these are really strong guys. They can create both chips and specialized drivers of the future, specialized drivers for powerful amplifiers. They work together with Infineon. In general, they do a lot of work on the amplifier. This is a Class D amplifier, and it's gradually becoming smaller and smaller for us. We're interested in a peak power of 500 watts, because it can handle any speaker, even a very demanding one. And as soon as this is thoroughly worked out, everything will be fine. We'll have an excellent amplifier at a reasonable price. And for those who shout, which, yes, for those who shout, which, and are looking for some kind of reason to say that this technology is bad, it will come anyway. It is so far ahead of Class B in all key parameters, especially in terms of thermal characteristics and so on, that there are no alternatives. It's about price, power, and quality. And someone in the comments wrote that Sukhov said there's hysteresis, but Sukhov is a well-known Soviet engineer. He was a great engineer who published in the radio magazine. I also subscribed to it and looked at these circuits. I was impressed too, but the philosophy here is that we are what we are today. What was in the past. This isn't the Olympic Games, it's the World Cup, and every year we start over. In general, Sukhov should be here. He should be dragged to the gallows, and he should shout that yes, the Class D witness zone has hysteresis, but I know how to solve it there. If you cut the ferrite, you can solve it. And then the next Hypex that comes along will be, I don't know, a Hypex amplifier with a Sukhov-Hoffman inductor. He is there. And if he's shouting from the crowd like, there's a witch and she's a redhead and young people just don't look back, then that's it. Old Grump. He should be able to use his intellect to solve the challenges of the future. And for those who are seriously interested in this topic, I've selected an article written by Bruno Putzis. To me, he is a sensei. He has truly done a great deal for Class D amplifiers and for the future. Here's a long article. It answers a lot of audiophile questions in a very competent way and so on. Everything is there. It's a long article. It's published, and we'll provide a link when we publish this video. Here is the author, Bruno Putzis. He started as a student, and look, he's already a mature specialist. And he did a lot to create those really cool Class D amplifiers. But the second one, who is kind of in the shadows, is IcePower. I only work with IcePower because they produce industrial grade units. They are very well refined and you can buy them at a retailer. They've supplied them to several large and commercial stores, and enthusiasts can buy them directly as well. Other companies don't do that. So even with Hypex, you can't buy the professional line directly, but you can buy it from IcePower. I only work with IcePower. But that doesn't mean Hypex is bad. Hypex is very good. They are the same. They use the same technology, the same principles, the same architecture. So, well, as for me, my focus is 100% on Class D amplifiers as the amplifiers of the future. I don't want to be like Nokia saying that button phones are good and then it's over. Well, that's in some way my answer to the skeptics of Class D. I think the biggest risk for amplifiers in the Class A and B amplifier market is the TPA3255 chip. The Chinese have mastered it, and you can really build a 250 watt clean amplifier at 4 ohms with it, and at 8 ohms that's 120 watts. And that's the niche where Class A and B can compete with the TPA3255. But the designs based on this chip are smaller in size. The Chinese have mastered it and are now flooding the market with their developments, and they're getting better and better. And basically, there are no complaints about these amplifiers. Where the power is higher, up to 500 watts, there aren't any good Chinese ones yet. Those tasks are much more difficult, but up to 100 watts, that's all covered.